Yesterday, we have seen the first part of the training explaining essentially the front-end technologies that we have behind MapStore. We explained the syntax of ECMAScript new versions from 2015 until now that has been introduced and are often used are very used in MapStore. Classes, arrow functions, const, let variable declarations, optional chaining, nullish queries, spread but also which screen are you seeing? This one, isn't it? The slides, isn't it?
Perfect.
Okay.
Yes.
I was saying we have seen the ECMAScript improvements that and new features introduced from 2015 until now. So classes, arrow functions, const and let variable declarations, optional chaining, nullish coalish, but and also spread operator that is used a lot, and the structuring used a lot too. And ECMAScript default REST operators that is similar to the spread, and array map filter and reduce new functions, promises that are very important for the communication between the MapStore and the server. Let me admit the other ones and show and reshare my screen. Okay, and we have seen promises that are very important for communication with the server. Then I introduced React and Flux architecture. So the implementation of the Flux architecture we are using, so that is Redux. We have seen the concept of user actions, and quickly I've seen what is a selector, and in general, what is the loop involved in the evolution of the user interface and the state of the application, and how they fit together to create the final application. Okay. Then after introducing React and Redux, that are essentially the view part and the state of the application container, we introduced the Redux middleware yesterday to do async side effects, basically, that are because all these flow to update the state, update the view, and trigger an action that updates the state, updates the view, and so on, is synchronous, basically, at least in the Redux implementation. We have some, in order to do some AJAX request or some asynchronous things in general, or other side effects like modify use some browsers, the browser sees some other things apart from this continuous flow, can be implemented by using a middleware that can be attached to the to Redux in order to, for instance, do asynchronous request, and then we see the middleware, the Tank middleware, and then we have seen an example of how to do a request to a server and get a response and trigger an action to update the state with the response. This is an example Tank that does this, and at the end of the meeting, I introduced a library that we use in MapStore that is Redux Observable, that allows to do asynchronous flows, but without the limitation that Thunk has, like intercepting actions during these asynchronous requests, allow to the cancellation of the requests or cancellation of complex data flows in general. So I explained with a dedicated presentation this library that is pretty new, and I explained the concept of observables, and with this that is an object with basically these three handlers. But in MapStore we don't use these handlers directly because it's a little hard to do, but instead we use the RxJS library that provides a lot of operators that allow to create and parse these streams of event that are basically what the observable representation is, and manipulate the events that flows inside these streams to filter, to create new streams or new streams of event from beginning from events received and so on. There are some complex operations here and there that allow to manipulate the events coming from the user interface or whatever application you want in general for the library. And filter, the bounds, for instance, is another example that can be explained to avoid to emit to emit too many events in a time span, to emit only the last one, for instance. It's useful for continuous typing. If you search while typing, you don't want to search all the keys that has been typed, but only the last one, the last string, the last updated string. If you, for instance, this is the typical example. If a tool searches while typing, I don't want to search on every single character typed, but I want to search only at the end of the writing, and the bouncing is this operation is provided by many libraries. For instance, Lodash has the bounce function for it, and also one of the operators in Redux is the bounce, for instance. And there are many operators. They are reachable from this link. We are using the version 5 of the library. There is a version 6 and a version 7 going to be developed, going to be released for Redux Observable, and we didn't migrate it yet. Anyway, if you open directly the site, you will be directed to the documentation of the new version that has a lot of syntax changes. So pay attention to use the proper link. Here we have okay, this one. I can find the documentation somewhere. They changed something in the documentation too. Let me find out. Okay. I don't have the link of the new one, but it is this one, yes. More than, let me share my screen again. We have here we have a different syntax, a little different. So pay attention to follow this link. I'll give you anyway. It's provided by the documentation, and as you can see, here there is some information about the version 6 and what changed. Essentially, they changed from object from this dot notation. They move it to a more functional notation. But anyway, all the concepts are the same, only the syntax of how to write observable changes. We will migrate in the future. There is a compatibility library here in order to start developing with a new language, but we didn't introduce it yet. So the link is this for the moment to get the documentation for our purposes. Then after introducing observables, I introduced Redux Observable, that is the library that we use, the middleware for Redux that we use. That is simply a library, a middleware that allow to create some functions called epic that has as argument first argument the action stream, the stream of actions coming from the Redux store. So it will emit all the actions emitted by the system, and it will return another observable with the actions that the epic want to emit. So for this is very useful because you can intercept some actions from the system in general, use some fake actions that doesn't modify the state, for instance, and only trigger an epic that trigger, for instance, some changes on the some changes on the that trigger, for instance, a request on the server, and then emit the new actions with the updated state that updates the state with the results, for instance, or anyway reacts to any event with another actions or many actions as you want. And you can create subflows that intercept actions starting, for instance, a subflow and intercepting, for instance, if you want to start listen for clicks on the map for a particular event, you can have a button, for instance, that tells the application that that is in edit mode. You
Hello.
click. Hello.
Lorenzo, can you tell us? Keep on sharing your screen, please.
Okay, I forgot it again.
Yeah, I was asking.
Yes, yes, please.
Regarding the delay, what is it all about?
Sorry?
A delay within that algorithm that you was displaying there.
Yes, I'm displaying what we did yesterday.
Yes, yes, that's one. That slide. The delay part.
Yes.
Why is it important to have that delay part within that?
Yeah, this is only an example. For instance, here we have an immediate operation. We have some operators, for instance, to delay some. It's possible to, for instance, for a game, for if you are doing an operation that needs a delay, you can delay the request. Or if you have to wait 3 or 4 seconds because before to reject a request, for instance, you can use a delay. You can emit another actions that cancel the request if it's taking too much. There are many useful. There are many use cases that you can use the delay operator. Basically, these intercept this first row intercept and filters the action coming from the Redux infrastructure can be another epic can have emitted it, or I click on the mouse and the dispatch function inside the connect can dispatch this. Anyway, once it has been intercepted, this event flows inside the epic, inside the stream, and you can delay this event. And map2 allow to react with an event with another event. Let's see a little bit. Let's see this example more. I remember that there was yes a useful site. I share it in the chat. This site is very useful to understand the operators, because you can move the events coming from, for instance, the from we have seen creates three for instance, creates three events. This is the delay of time, and so this is there are many examples for it. This is the creation also observable. Then for instance, we have seen the filter that, as you can see, filters events, only events that are more than 10. And here you can move these balls to understand what happens in time. And I don't know if a delay is here. Yes, it's here. Basically, delay does this. Takes the stream, you apply the method, and the delays of total amount of milliseconds later the event. As you can see, if I send the events a little bit later, I will have the effect of having another stream applying this delay with that emits these events a little later. We can see also the flat map, the switch map we have seen. Switch map, as I said yesterday, was an operator that on every event cancels that creates a stream and flatten all the events emitted by the stream created in the resulting observable. And if it receives a new observable, a new event from the first observable, it stops emitting the events from the previous stream and creates a new one. This helps you to understand that if I move, I emit an event before this stream, for instance, gets the observable one, and then emits a string that concatenate that takes another observable here. I have another observable here, for instance, and I concatenate I join the string coming from the first event. I emit 3.3 numbers in sequence, and I join the two strings. As you can see, as well as this is the string created by the observable. This is the original string that receives the events. Is that clear? Then you can see that the switch map, if receives another event before this internal stream is completed, stops emitting the original events and starts emitting new events. Starting from the new event coming from this input stream. Okay, you can play with this tool that is very fun in order to understand maybe all the operators. Anyway, we will today we will try them. So the important things that you have to take into consideration is that Epix receives actions from the systems and emits new actions on demand, what you want, by using the stream, the RxJS operators and RxJS utilities to parse the flows. Is that clear? Did I reply your question? I went a little bit further, but I think I hope I replied your question.
Yeah, I understood you.
Yeah. Okay.
Thank you.
Okay. Then here, more or less, as I said, yes, there are many operators, but these are the most used filter. We have seen it. Map more or less is similar to the map for arrays, and there are many of them. We will see a couple of them while developing the plugin. Okay. I want to show you this in animation just as a summary of what you have learned about React Redux. It is a little hard to follow, but if we take a look at it a couple of times, we can understand it. Basically, we start from the view. For instance, from the view, the user clicks somewhere now, and it emits an event. The event is translated in an action. The action somehow is it's too fast anyway. Let's restart. The event is emitted by it emits an action. It received from the store. Let's for the moment let's ignore this part and only follow the big cycle. Event translated with an action dispatched to the store. Reducer and state has been updated, and the state is updated to the view. And once again, event, action, dispatched to the store, state update, state propagated to the view, and so the view is updated in this case. Now let's see the last part. The action have a side effect. For instance, we do a request to the server that emits another action, and it is propagated to the reducer, and it updates the state again. Let's see the full cycle again, last time. From here, for now. A user clicks, for instance, an action is emitted, a request is sent to the server. In the meanwhile, the states update, the request response, and the states updates again, and the view is updated, and so on. This is the more or less the continuous flow that happens behind the Redux React Redux application. This is very useful to summarize somehow all the events and all the changes happening inside the application. Is it clear? It's a little bit hard to follow in a startup, but if you take a look a couple of times to the animation, it should be useful. Can I go further, or it's not clear? Do we have some questions? I can go to the MapStore section. Can I go?
Yeah, I think let's go.
Okay. If there are no questions, I can go further. So let's begin with today's lesson. Okay. Today we are going to talk about MapStore, finally, and eventually, and we will talk about the architecture of MapStore in general, because it is a product, first of all, and when you develop, usually you will have a backend in MapStore, but you can also have, you can take the same informations to understand also the GeoNode implementation. And so after the architecture has been is clear, we can pass to how to build MapStore, and in order to run it and deploy it, and how to develop it. These steps helps you to start understanding the internal structure, and then well understand where are the important points where you have to focus on when you develop. Okay, as we said in the previous lesson, it's MapStore uses JavaScript, React, and Redux. It's 99%, 90% JavaScript, and the part used by GeoNode is only the JavaScript part. And it provides basically a framework to develop your own plugin and to include them. In general, it provides a plugin system that allows to develop separated units that can be included and injected into the user interface in order to add to the application your own parts, and of course it provides a lot of predefined tools from common mapping functionalities and for sharing maps and everything we have seen in the product yesterday. Other than the plugin system that allow to develop single units that can be included in MapStore, it provides also standard app and standard store that are simple entry point in order to avoid to create Redux store. There is a new unique Redux store and a unique application you can plug in your plugins and your parts. So you don't have to care about the structure, but only develop your own reducer for your own piece of state that you're interested to, or you can get state from other components if needed. And it provides the functionalities to develop your application. You can write your own application, your own UI, your own reducers, your own actions, and join them together into a plugin to put inside MapStore. MapStore is also a framework to create other than the product that can be installed and deploy on a server. It is also a framework, as I said, and it has a project creation system that allows to create some sort of clone of MapStore that uses almost everything from MapStore and allow you to isolate your components and for your custom application. So you can use MapStore as the base to develop your own application, adding only your plugins and create a separate application that uses MapStore, but it is not the final product. This will be more clear when we will see how to create projects and so on. Last but not least, mapping library agnostic. So it uses independently open layers, leaflet, Cesium, and we are going to evaluate all the mapping libraries. For instance, we in the future, if some of that libraries disappears or is not used or maintained anymore, MapStore can still live without it and continue using other mapping libraries that are that are used in that period. Basically, as I said, this is more or less a schema of what we have. We have some all the plugins introduce in the application some reducers and some actions and some components. Here the division is between smart components and dumb components. Dumb components are components that are not connected to the state. Smart are the ones that are connected, so that they use the function connect. We studied it yesterday, but anyway, we will use it so we can refresh the memory of that. And this is the cycle we have seen a couple of times. And for the mapping library, a component implements leaflet or the implementation for leaflet or open layers. So you don't have to care about open layers or leaflet, but you can control the map from the properties as all the other components in the application. You can use the same programming paradigm for every component and even included the map. And sometimes you have a communication with the backend also, and because it is a single page application, basically all the interactions comes from are usually applied to you doing AJAX requests, so asynchronous requests to the backend. Now we are talking about the backend. Let's clarify what is the backend for MapStore. Okay, in GeoNode, backend is GeoNode. In MapStore, there is a Java application written in Spring MVC and using and other technologies coming from all other projects. And they are typically they are three main parts. The MapStore backend that is included, that provides base settings, base services, and it has been introduced very recently. This part in the last release that has been released yesterday. So this part is very new and contains useful backend service for data directory, for extensions support, and so on. New features of the new release. And before this, the backend of MapStore was only made of two parts: Geostore. Geostore, that is the main part, and it is the backend part that provides users and authentication system. This is one of the core parts of Geostore, and the other part is the resources access system. Here in MapStore, you can see that you can log in, and login is provided by Geostore as well, and you can share resources like maps or dashboards and stories. You can share them with user groups and so on. And these resources handling, managing system on the database is managed by Geostore. This is the role of Geostore. Then HTTP proxy is an utility to support some cross-origin requests in order to allow MapStore to query also other services other than and avoid somehow with the security included the cross-origin limit, the cross-origin, sorry, the same origin policy of the browser. It's a very specific application for that purpose. So we have the front end. Here the front end collapsed in this rectangle, and we can see the backend detail. So we have Geostore that provides users and resources and rules to access to that resources, and they are stored on the database. Then HTTP proxy that allow to access to external web services. Then this is the third part, essentially, that allows to the MapStore part that allows to access to provide some features coming from the latest release. Anyway, if you will develop on your node, you will not be so interested on that, because if you're developing on your node, they are not yet included, and they are not part of the actual implementation in your node, but only support some useful features. If you want, I can explain it. I've shown you this context API. Basically, in this context API, you are able to import plugins and install them in the application. This is one of the features provided by the new backend part, specific of MapStore. You can install plugin in an existing instance of MapStore, and this initial support to installation of plugins is provided by this backend service. Okay. So you have a front end and a back end, and how the application is built together to provide front end and back end in a final package. Typically, MapStore is as a product is deployed in a WAR file, so is an web archive file. Is a zip file basically that contains an application for Java servlet containers. Can be deployed on Tomcat or on other servlet container. The most famous is Tomcat, and we use it a lot. But anyway, it should be there are other existings, and you should be able to deploy it also on them. To understand how we create the final Word file, we had to talk about some libraries. As I said, there is a JavaScript fatigue, known as JavaScript fatigue, that there is a problem of developing applications in these years because we have many libraries behind and big ecosystems of libraries behind JavaScript. Every application uses its own, and so we attempted to use as less libraries as possible. But anyway, there are a lot yet, but they are not always the most common, but almost always the most common. First of all, and other than this, we have the Java part. So let's begin from the JavaScript part. MapStore is an application that is built by using a Webpack, that is a module bundler. It's an application and provides also the dev server where you can develop the application, and you can find some information about it here on its own site. And basically, it takes all the JavaScript files in the applications and creates bundles. So you can get a lot of modules in your application. MapStore has a very big. This is MapStore. MapStore has a lot of files, as you can see, and they are bundled all together in single files that can be downloaded. It's useful to provide a single or some bundles that can be downloaded on demand anyway. A set of limited elements that can be downloaded in your application. So this tool allow to get all the files from MapStore, all files for actions, and etc., and compact them into small bundles, and even compress them in order to to have static assets that can be used in a web application. So Webpack takes these. Let me close some tabs in order to not confuse. Takes these files from our application and from npm, that is a dependent JavaScript dependency manager. You probably have seen it if you're developing in JavaScript. Allow you to manage your dependencies basically and download them. So here you have a packages.on file, typically in an application that uses npm that provides all the dependencies. These are for dev, these are for MapStore in general. These are the dependencies. They are downloaded in a directory called node modules, where you run npm install. When you run npm install, that is the first command that you have to run, you will see a directory called node modules in your root directory that contains all the libraries here. And Webpack will take the files from a typical file in MapStore has some includes some imports on the beginning that imports some library. For instance, here I'm importing some commands from Lodash. Then also other includes from other libraries, and export something. Webpack gets all these import commands and from external libraries or from internal your own system, and put them together into a bundle or one or more bundle depending on the configuration of Webpack, and to create a final application. And it uses Babel, that is probably included as a loader for Webpack. That is a library that allow you to translate ECMAScript 6, 7, 8 until 11 into a code that is understandable for all the browsers. Sometimes we say it is transpiled because it's not compiled, even if it's named like this. But sometimes we used to say transpile instead of compiling because it's translating in the same language. It's not compiling in machine language or another code like bytecode. Is for this reason someone says transpiling is instead of compiling. So basically we have seen Webpack that create bundles, getting libraries from npm and from in JavaScript, our own JavaScript file, and put them all together with the HTML files, less CSS files, and so on, using Babel to translate. Somehow it compresses also the things and the file to as much as possible, and it creates a dist directory. When you compile, you will see npm. If I compile, everything will be this is MapStore directory. All the JavaScript files are here in web client directory, and when you compile, you will see this directory. When you compile, that contains all these are the chunks of the files that are created, and these are chunks for smaller libraries loaded on demand. And the main bundle is called MapStore 2.js. That is a compressed file. I try to open it, but anyway, it's not so understandable because, as you can see, it has been compressed, compiled, reduced in size, and all the strings has been compressed as much as possible. So it's hard to read it. This is the final set of assets, so the set of JavaScript files, HTML files, less files for the front end. Apart from that, we use a Karma directory that does unit tests. Anyway, it is a test runner, nothing important for the explanation today. And the final Java application is created by Maven, that is a framework that allows to create a Java application, and that gets the Java part, so all the backend, Geostor, HTTP proxy configuration, etc., and put it together with the dist directory and create the final Word file that is that contains the application, the final application. Basically, all the index HTML are HTML files that can be used by a Java application, and they are included together with the JavaScript files here inside that, and together with that HTML part, HTML JavaScript part, we have a backend services system that is included in this package, and it can be deployed inside of Tomcat, for instance. So, as I said, there is in MapStore there is a build.js scripts, build.sh script that allow you to run to create the final Word file, and there are some commands to execute tests, generate documentation, and so on. But the important part is this, basically, these three commands: npm install to download the npm dependencies, npm run compile that does this creation of the dist directory, and just a second. And at the end, the Maven clean install operation. Maven install is sufficient. Cleans the previous created things anyway. Maven install is more than sufficient. That is more than enough, and it downloads Java dependencies and build the final Word with dist, and you can find the final file in web target directory. If I run build.js at the end, I will have, I already did it. I think you can find the target directory that is created by Maven, and here you can see the mapstore.war file that it can be deployed in Tomcat and used. This file can be deployed, as I said, in Tomcat. By default, it uses an H2 database. This is this configuration is not suggested on production because the H2 database has some problems, can be used only in test or single user purposes. So in the documentation, you can find the guide to connect your own database. PostgreSQL and Oracle are supported in order to have MapStore in production. And that's more or less that everything you need to know about installation of MapStore, only configuring the database and using it. There are some, in the documentation you can find also some other utilities to integrate to GeoServer, with GeoServer or with LDAP. Of course, in GeoNode, this is already present because GeoNode is already integrated with GeoServer. and the user system is the one of John Newton. It doesn't use the user system of MapStore. So I will not go too much deep into this, but if you want to download MapStore for instance, from GitHub, you can get the latest release, officially released yesterday. We created the bundle a couple of weeks ago. Anyway, the message, the email on the main list has been sent yesterday, and you can download store.org on your application, on your Tomcat, or download even the bundle, that an application that contains a Tomcat inside. So you can simply download that and run the script for setup, and it will start locally. Okay. Let me recover the point I was where. Okay. Last thing, but it's not important, is documented. By default, when you start this MapStore, you have two users, one admin user with password admin and a user with user named user with the password user. Questions for this part?
Hello, Lorenzo.
Hi.
Is there any documentation that we can get for the how to install this MapStore in our machines, both production and development?
Yes, the documentation of MapStore has evolved a lot. Store, sorry, MapStore, MapStore.readdocs.io is the main documentation, and here you can see the developer guide, quick setup and run. Sorry, developing, deploying. There is anyway here you can find the installation guide. I don't remember if it is user or I think it's developer guide. Requirements and or installation. As you can see, it's simple. And databases, here you can find the database setup entry. How to set up database. When you install the WAR, you can set up the database, and moreover, you can use even integrate to Geosolutions and end it up. Anyway, the only thing that you have to do if you are a user, a person that want to install MapStore as it is simply to download it and run and install it in Tomcat. So deploying and move it in the web apps directory of Tomcat and start the Tomcat. This is the main operation you can do. Nothing different from other Java applications.
And that one can be development side, the one that they want to change me for the development. If I upload theirs to web apps and Tomcats.
Sorry, can you repeat?
I mean, that one you say that if I download from this one and put the web apps there and the Tomcats, I can use as a development side or just for production?
Just for production, yes. If you want to develop it, yes, I'm going to explain how to develop it in the next section. You can build it from development running build sh here. But first of all, let's start from the beginning. You open you get and you clone the repository of MapStore. Maybe this was not clear, and install and you download it in your doing git clone and your application. So git clone and the URL of the main MapStore repository. This is what I did here. I already did it here, and so this directory. Let me explain a little bit more, because this question is correct. It is very useful. Here in my project directory, I executed first of all git clone and the URL of the Git repository. This allowed me. This creates a new directory called MapStore2, and here you can find that there are a lot of directories here. Sorry, let me collapse them. This is, let me open it in Nautilus so it's more clear for you. When I download MapStore, I have a new directory called MapStore2 here, and you have some directories that I will explain. Anyway, here, if you open the console from this directory, you can run build.sh, and it will create the final war in a web target directory. This, if you developed something and modified something, you can build your own version of MapStore, or you can, for instance, improve MapStore with some fixes and so on by doing that. When you sorry, there's a lot of noise. Sorry, I have to mute someone. Okay. This is if you, when you develop, let me share the screen again. This is when you, now I stopped at build because it takes a lot, but anyway, and this is when you build the MapStore as a product. Okay. Basically, when you want to, so this allows to create a final war with Java part together with MapStore part, with the front-end part. Now I will explain how to develop in both the places. So you can, after developing, you can build, of course, the final war and deploy somewhere. Anyway, you have an environment to, of course, test it locally and run it locally without deploying it in MapStore. Is it clear? I know that I have to explain a little bit something else.
Yeah, it's clear, I think, for
okay.
the concept. Thank you.
Okay. And okay, now let's start to run the application in developer mode. Make sure to run after cloning and go and doing cd into the directory. Make sure to run npm install at least once at the beginning or when you update some dependencies in order to download all the dependencies. It can be done only once, as well as you don't update the dependencies is not required anymore. If you update MapStore from some dependencies may be changed. So when you get, I don't know if you are competent with Git, but to get updates from Git, you usually do a git pull command that gets all the, for instance, now for sure I have some updates, and if packages unchanged, typically dependencies changes and you have to run again npm install to download the latest dependencies. Anyway, I already run it. The changes I downloaded that has been probably developed today or yesterday on MapStore master branch are doesn't contain any changes to dependencies, so I can only start developing mode by running npm start. Npm start, we start the webpack dev server that I introduce it a little here. That provides, as I said, it creates the bundles, but provides also dev server to emulate these bundles and allow you to debug in not compressed mode. Webpack creates the bundles, unreadable bundles I've shown you, but when you develop, you want to read the code, of course, and so Webpack provides also a dev server that has been started running the command npm start. And in this mode, all the files included as libraries or as models are not too much modified. A little bit are modified because of performance issues, but anyway, they are still readable, and so you can use it to debug it. To debug the server. Once yes, now it's running, and you can find the application running on localhost 8081. So the application now is in debug mode, in the development mode. MapStore is running locally. The backend part is still using the dev server I've shown you sometimes. By default, MapStore uses this development server that is the backend part. It uses the backend part of the development server by default. Let's summarize because I introduced a lot of information, and so let's recap a little bit the points we followed, so we can continue on developing on developer parts. So let's summarize. Front-end, backend, MapStore. Front-end is a JavaScript application, single-page application. Backend is a Java application, as in the product mode. They are built and put together using some libraries. The important ones are npm for dependencies in JavaScript, Webpack for bundling, and Maven to create the final war and put together the Java part with MapStore. As you can see, in order to run MapStore in development mode, you have to simply, in order to compile it, you have to simply run the build script. So these are the important points of the script. But anyway, to build, you have to simply download, of course, the Git MapStore from Git and to go in the directory and run the build.sh script in order to build the final war. And in order to instead run in development mode, you have to run at least once npm install at the beginning, and then the only command that you have to run in order to start developing is npm start. This command will start the Webpack dev server in localhost 8081. Okay. This part runs only the backend, the front-end part. npm start runs only the front-end part, so only this part of the application is emulated by the Webpack dev server, only the part in blue. The part in red is still the part in red is used by default. MapStore uses this dev server to run the backend part. In order to run locally also the backend part, you can install MapStore war in your application in a Tomcat locally and run it. This is very simple. You can run the dev sorry, And as I said, Webpack Dev Server uses the backend service, as I said, the dev backend service, and in order to use a local instance and run everything locally, you can simply download or build your own MapStore or locally, and edit one file of configuration of Webpack Dev Server to a point. Instead of using a dev server, instead you can use your localhost application. Let's do it together. Now I have a Tomcat here somewhere. I think I have work programs, Apache Tomcat, web apps. Here I have already an instance installed of MapStore. So anyway, the only thing that you have to do is to copy a MapStore here and copy in the web app directory of, you download Apache Tomcat, that is a package, and you extract it in a directory of your own. If the Tomcat will contain these directories, basically these files. You can put simply the MapStore wall created by the build sh script into this directory. You can drop it in this directory. Then here you can open the terminal and run the script and start up Tomcat by running bin startup.sh. This will start Tomcat. By default, Tomcat runs on port localhost 8080. And here in the /MapStore, we'll find MapStore running as well as its stars. It's going to start. There are some application in there. Anyway, yes, now it's starting. As you can see, now I have deployed MapStore war in my Tomcat, and so I have the default user and password. So admin to log in, and here I have an empty version of MapStore that I can use as backend. Here I can stop my Webpack Dev Server and change the configuration in order to point to my local MapStore backend services instead of using the dev.mapstore.geosolutions.it. To do this, you have to edit a file called build as. In build directory, there is a file called buildconfig.js that contains all the configuration, and you have to change these entry points to change HTTP protocol because HTTPS locally is not. I didn't install any any certificate, so I can use simply HTTP and replace dev.mapstore.geosolutions.it with the address of my local instance of MapStore backend service, that is localhost 8080. So let's do it. Build.buildconfig.js. I open this file. At the end, we have some, here we have all the configuration for the build. There are a lot, but you can concentrate on the dev server entry. There is a proxy that provides some targets, and you can replace all these strings with host 8080 and also replace HTTPS with HTTP. Also the proxy, I forgot this. now, if I restart again, I usually run the commands from the integrated terminal of VS Code, Visual Studio Code. This is the ID I use, and this is an integrated terminal. So writing commands here is the same of writing commands here in the terminal. So npm start. Now I started the webpack dev server to point, changing the configuration to point in my local instance of MapStore instead of the backend service that is the default. Instead of using dev.geosolutions.it, etc. Instead of using this, I'll use localhost 8080. Localhost 8080. MapStore. Now pay attention. Then when the build is finished here, when the dev server has started, you will see that instead of having this, now I refresh the page, and you will see that I'm connected to the local instance, so I will not have the maps coming from dev.mapstore.geosolutions.it. I don't have. Okay, now stop is started. So you will see that this now loads contents from localhost 8080, and so I can log in instead of using the password. I can use the local password admin, and I can start using the local backend part also. This was a difficult thing to do, but now you have a full set of backend and front end running locally. Usually, when you develop on MapStore, 99% of the time you develop on the front end side. So running the backend as locally as it is as a product is more than enough. So, okay, please tell me.
Can you change that language to English, maybe?
Yes, language of MapStore, you mean?
Yeah.
Yes. Okay. Sometimes, yes. If I refresh, unfortunately, yes. Now I have.
That's good.
Yes. Now I have a clear instance of MapStore. Thank you. Please tell me if sometimes when I refresh it's not clear because the language is reached again in Italian, because the browser default is in Italian. Let me find out if I can change it from the settings. No. Okay, now if I restart the browser, now it should be in English. Let's try. There is a lot of suspense. Yes, now is the default language of my browser is in English, so it starts in English, and we don't have to care about it anymore.
Thank you very much for your effort.
Okay.
Thank you.
Okay. I cannot change the language of the IDE so simply. I don't know how to do it. Anyway, I'll try to translate as much as possible when you see some menus here or something like that.
Worry not.
Mm-hmm. Okay, so summarizing the last part, then we can do a pause if you want. I can get again the Okay. So, summarizing, now we are able to run the application in dev mode by using the backend locally and running the front end in dev server of Webpack. This is the important part. Now here in this mode, you're able to, for instance, let's create a new map just for instance. You're able to use the developer tools, and the sources are for instance, here I can put breakpoints here in the developer tools. You can open the developer tools by tools, developer tools, open sources here, and here you can type, for instance, ctrlp to find out the files you want to debug. For instance, I can intercept the reducer or the actions for search, action search. For instance, I can intercept when the action creator of text search change is called, and I can type search, and you see that I'm in the bug now, and I see all the text inserted, and I can go back to the call stack and understand where it has been called. This is the component, the search bar input component that called the action, and it has been dispatched by the framework, and then the action has been performed. So here I can even intercept the reducer part. Here I already put I can use the reducers search, and there is already a breakpoint here. I can go further, and I see that now the action has been intercepted by this reducer, and here you can see the old state of this reducer that has only the style, and you can see that the action received contains the search text, and the next state will be, I can execute this command, for instance, in the console, and see there you can debug everything and try to execute some code here and see. As you can do normal debugging, and you can see values of the variables and so on. And moreover, you can even use the same the bug root flag here that I explained a little bit the last time, the previous lesson. And now you have another tab here called Redux with all the action triggered and all the state of the current state of the application. Here you can see every entry here is a reducer, is created by a reducer. This is the returned values of every reducer. This is the full state of the application. You can see this is collapsed, so you can expand. This is the full state of the application. As you can see, there is a reducer for layers that shows all the layers in the map. There is a reducer for map. I can find it. Where it is? Yes, here. Here there is also the history here. So as well as I change the history, the past array contains previous states. And here you can see the center of the map, the zoom, the max extent, and all the information of the state of the map. For instance, the resolutions and so on. the projection, the current projection, and the units of the map. So as well as I change position for the map, you see that I received a change zoom level action triggered that changed the new zoom level here. This caused a change in the map.best. As I said, there is an history here for the map. And in the new state, the zoom variable changed, and you can see you can see that now the full state is has been changed. And for instance, I can change the position here, and you can see that the change map view is triggered. And if you see the present of the map, now the center has changed, and the bounding box too. So every action you trigger causes a state change, and this is accessible to every other tree, and so you can use this state and use this tool to debug and to understand what's happening to the state. Okay, if you want, we can take a break. If you want 5 minutes, or if you want a longer break, because yesterday we ran it a lot, so we did only a 5 minutes break, but now we can have a 10-minute break. It's okay for you?
Yeah, it's okay, I think.
Yes.
Break.
So we can find out, we can restart from 20 past 11 in our time, but anyway, in 10 minutes. Okay?
Okay.
Okay, thank you. See you later.
Meeting is being recorded.
Okay, let's start again. First of all, questions. Are you there? First of all.
I am.
Okay. At least someone is there. Okay. Let's start with summarizing what we have learned before. We learned how to build a MapStore product with the main parts, that is the backend and the front end, made by the system of users and resources. The backend is, the front end is basically an application made with plugins and so on, and the backend is made by 3 parts: one specific, one for handling users and resources and permission on that, and then some additional services for specific purposes. Or another part is the printing tool and so on. There are some specific parts beside.
Screen, yes.
Oh, yes. Sorry, I always forgot. Okay, now we can see it. Yes.
Yes, we can.
Okay. Thanks. Please remember me if I forget to share the screen. I see that today and even yesterday I did it a lot of time. Okay, so we say that MapStore is made of front-end part written in JavaScript with React Redux with a plugin system and an application that provides a framework that provides the tools to develop plugins independently. And the backend part is a Java application containing the system of users and resources and how to the permissions to access to them, and then some additional services for very specific parts. We learned how what are the tools involved in building a MapStore application. The MapStore, we learned that there is a part, a JavaScript part that builds a dist directory where all the assets, all the static assets are compressed into small and more less in number and less in size files in a dist directory. That this directory together with the HTML, etc., is included in a in the Word file together with the Java backend by Maven. The first part is the first build part creates all the bundle, the static assets, and the final part creates the final Word file with Java backend and also with this index HTML and all the connected JavaScript inside. Then we learned how to install MapStore Word in a Tomcat. Simply download Tomcat or install Tomcat in your machine and put it in the Word in the web apps directory. I don't want to talk about how to set up the database because it's boring, but anyway, you can find this documentation online. We used this deploy in order to have a backend running locally for MapStore develop environment. We start the front end by running npm start, and this command allow to run MapStore with the JavaScript exploded, so you can debug it in localhost 8081 at localhost 8081. I explained how to configure the buildconfig.js in order to use local instance of MapStore as a backend. Let me restart sharing. We learned how to use this backend, the backend that we installed locally as the backend for the development environment, and then I started explaining how to debug the locally. I explained how to put breakpoints in files. Now we will see more in detail the files in MapStore, so you can understand which files are present and which probably we will have to debug. And I also explained how to turn on the debug mode of Redux and how to check the action triggered in the Redux store and the changes, how to explore the history of the changes during the application execution. Okay. One note about this: while debugging, you will find you will not find the real file. If you look at this file, search reducers.search.js file, you will see that there are some requires. We will see they are more or less the same of imports. I will explain a little bit better later. Anyway, these are these imports information from other files, and here in the debug of the browser, in the debug tool of the browser, you will see some additional things or some strange replacement that Webpack does. And you will not always see the full exactly the same file you find in development. This is especially true for components. For instance, if you look for the search bar input, you will not see the if, and let's open it. Okay, I found you here. You can see some JSX, but here you will not see JSX, but you will see some. This is React.createElement. This is because Webpack have several ways to build the code for debug and doing the mapping. In MapStore, we use this. This is configured in the same build config we have seen here, that tool. And in MapStore runs in eval mode. There are several ways that when you can set this variable. We choose eval because it's faster and generates a code that is almost it's even readable, but there are ways there are other settings for this setup that allow to have the code more similar to the initial one, but they are slower, and so it's hard to develop in that modes. We found out the eval mode was the faster in terms of build and rebuild the generate code while typing, while creating modifying the code, and it was for us the best compromise between performances and readability of the code in debug mode. You can change them if you have a supercomputer or something like that. You can try to change them in the way you want. I prefer to use eval because anyway I'm habituated to to look at the code for it, but you're not forced to use this way if you are not confident with it. Anyway, you will see that the build when you typically when you develop you change something here. You can add another attribute, for instance. Here I added dummy code, and as well as you save, you see that the compile starts automatically and it's almost immediately applied using eval. So you can it automatically refreshes, and so you will see your changes almost instantly. If you change that that parameter, it will be a lot slower. If you use, for instance, another setting that allow to use source maps and something like that, but it will be more readable. It's up to you if you want to change things and you and make the code in the bug more readable. Anyway, here I think it's an all readable to the bug, because the only thing that you have to understand is if you have a JSX, it will be transformed into a create element, and the attributes are passed as an object. And if you understand this, you can read also this code in the debug mode. So. We already did this. There is another note about debugging backend, but I don't think you are interested too, because you are more interested to the GeoNode part that doesn't include the backend. Anyway, you can set up. There are some guidelines online to use JPDA, that is the the debugging system of Tomcat of Java and set up a Tomcat to use this debug system, and you can use Eclipse, that is IDE for developing Java application, in order to connect to Tomcat in debug mode, and you can debug also the code of the backend. But as I said, just for instance, just to explain, in the backend part of MapStore is developed only by me and another person in the whole MapStore team. That is the core MapStore team is 10 persons, the people, and only me and another maintain, and we don't do too much changes to that part. So just to explain that most of the work that you do on MapStore is on the front-end side, and if you are interested to GeoNode, it is only the backend is not used. So this is not important at all for you. Just a note if you want to fix, or if you want to enhance the backend, this is the way you can do it. Okay, so we can start exploring MapStore in order to understand how it's made, where are the pieces of the code we are interested to, and to start developing a plugin. If you take a look at the tree, there are in the root we have several files for build in the build directory. Let's and there's some files that are required by many tools like documentation by Travis, that are services for automatic testings and so on. You may be not interested for it at the beginning, and the only thing that you are interested to is the web directory. The web directory contains the POM XML, that is the Maven entry point that allow you to build the final application. And then the front-end part is in the client directory. So when you develop on the front end, you will work in the web client directory. Web instead, the other directory that is present in the web directory is src, that contains the, as I said, the backend of MapStore. This part. The other ones are included as external dependencies from Maven. This is the src directory contains the Java files only for this part. So if you develop on MapStore on client side, you will probably work with web client directory. So let's concentrate on this directory. And the web client directory has an index HTML file that is used in debug mode. So I took the wrong one. There are some example that contains also index.html, but it's not the case. Index.html. Yeah, this one. This is almost empty. It has some. This is the style for the initial loading spinner, in order to show the spinner before the application is loaded. And then it includes some external libraries, for instance, for leaflet or Cesium and so on, or CSS. And it includes, this is the spinner, and this is the style for the spinner, and this is the spinner. And then it simply includes the bundle dist MapStore2, that is the main entry point here. As I said, the dev server of Webpack emulates these JavaScript entry points and use it to import all the unbundled files that you can search in the developer tool. So this script inclusion download the JavaScript file generated by Webpack dev server, and it includes all the files exploded in order to debug. In the when you deploy instead, you will have an index.js similar to this, but the bundle is a real file with all the files, with all the MapStore application compressed, and it will include also some small bundles here and there on demand, but the main entry point is a real file. Instead, in dev mode is emulated. The production file is created by Webpack using this index template. That is almost the same file, but here you cannot see this file because these templates are created only for only to one hash when you build MapStore in order to avoid caching problems. A hashed version of the MapStore bundle, something like MapStore2 dash and a code of the hash, a unique code of the hash of the bundle in order to avoid caching problems. This difference between index and index template, we will remove them in the next versions of MapStore if possible. Anyway, this is basically a copy apart from this script tag that is not included because it's injected on build time, but it's almost the same. Anyway, you will find them if you do changes on this, you will have to do changes on also on this, at least as well as we unified it in the next version of MapStore. Apart from this detail, you have the index file that is the entry point of the application. Localhost 8081 is this doing it. Probably you know that doing calling index.html or doing or not doing it is the same in the web application. It's implicit that you are accessing to index.html. So this is the main entry point. You will see other entry points that allows the usage of an embedded version that is a smaller bundle for embedded to embed in external applications, and the API bundle that allow you to run the API version of MapStore. We will see it later. Maybe this is a part that is also explained in the Genode version, because Genode version is a customized version of the API. Anyway, we have an index HTML that is a base entry point. We have older entry points for smaller or different version of MapStore, but it's for the moment is only sufficient that you know that they are there, but you don't need them yet. And then you have a typical structure of a Redux application that has a folder for actions that are actions creator. In fact, action folder contains web client actions contains several files, one for each reducer. Usually you have the same name used for actions, and actions related to the same reducer. So for instance, here we have the actions for layers, add group, add layer, and so on, add group, add layer, remove layer, and so on. these are the types, for each type, more or less, you will have an action creator. Sometimes here you can find, in these files, you can find also tanks that will be treated as actions creator. As I said yesterday, you can dispatch actions or tank actions creators or tank, and if the middleware is in, they are automatically distinguished and used accordingly by Redux. You can find this actions directory for layers, and the same name files are for reducers. So if you open the reducers directory, you can find the layers reducer that typically intercepts actions like, for instance, layer load. You can find add layer that gets all the layers, for instance, manage the groups and adds the layer, sort them up and adds the layer to the new list. Basically, it returns the new state with the new layer added to the list. Then you have a directory for components. For instance, the table of content for components that are React components. For instance, the table of contents, that is this plugin, this component. This, for instance, renders a component with class name of this. If you look at, for instance, if you look for this, I can find it inside. Let me try another example. For instance, the toolbar. The toolbar is this one. You can find it here. Oh, sorry, this is the toolbar of the table of contents. Sorry. Yeah. You can find, for instance, let me find out an ID so I can explain you what I mean. Let's use the search bar that we already confident with. You have the search bar input. We have here in the document we have this component. As you can see, there is the search input here as class name, and there is a property called class name passed to the component, and it is joined. This is more or less the same that doing this. It gets the class name and the here you can see that this input is generated by this component. So every component in MapStore, every React component more or less will be rendered as a tag in HTML. You can find them in the application. So actions, reducers, components, then epics that has the same name group of actions. For instance, for layers, you have epics for layers that creates some side effects. For instance, there is an action called refresh layer that updates the layers names and from the server and the bbox and so on. So if you trigger this refresh layers action, you will go into this epic and it will get all the information from the describe feature type or describe when or from get capabilities from the service of the WMS or something, or whatever it is, to get the layer information and update the title and description. Or another example can be in search. We have search actions. We have seen search actions. For instance, text text search is changed, the actions that we have seen yesterday. And we have a reducer for that called search. That intercepts this action and updates the search text. And an epics that intercept the text search started in this case, or whatever event to query the services, and this is the multiple service system that queries all the services available, and these intercept the responses and provides the results. This is the epic of the search tool. And this is the structure of every file, more or less. You will find the same naming convention for every part of the state. And most of the time, this part of the state is also part of a specific plugin. In plugins directory, you can find the plugins. Now we'll see what are the plugins. Oh, sorry, in the directory plugins, I said. The directory plugins, you can find all the plugins of MapStore. For instance, there is a plugin for login that implements the login tool, or the login tool. This is the plugin for login. A plugin for map that implements the map